Why does life exist only on Earth? Why not on other planets? The basic requirements for life to exist on any planet is liquid water, non-toxic atmosphere, and ideal temperature. Among all the other planets, Earth is the only one that checks all these boxes, making it the perfect cradle for life. However, popular conspiracies involving Elon Musk and Mars state that there is a possibility of life on Mars, and Elon's push for colonization is part of Plan B for billionaires when Earth becomes uninhabitable. And some even say that SpaceX has secretly launched a manned mission on Mars, and Elon Musk already knows what's up there. These conspiracies might be partially true. Recent scientific studies reveal signs that life might be possible on Mars, and that's what exactly we are diving into in this video. Ferrihydrite. This mineral might just be Mars' version of baby Earth with big possibilities for life. If life should exist on any planet, it should have favorable conditions like water, oxygen, and ideal temperatures, not too cold and not too hot. Now coming to Mars, Mars is also called as the red planet as its surface consists of 90% rust. Now you might ask me, if Martian surface consists of 90% rust, then how is there a possibility for human survival? To know about this, you should first understand how rust is formed. When iron gets exposed to oxygen and water, it forms a layer of rust. Here's the simple chemistry behind it. Ever left a slice of apple out for a while? It turns brown, right? You might also have noticed your gates, cycle, or anything made out of iron rusting. It all occurs due to redox reactions. It is a combination of oxidation and reduction reactions where electrons are transferred between substances. The ones which loses electrons undergo oxidation, and the ones which gains electrons undergo reduction. So basically, oxidation plus reduction is equal to redox reactions. Redox reactions are literally the engine of life. In fact, your body is a giant walking, talking redox machine. Breathing, photosynthesis, and even the way your cells produce energy, all powered by controlled electron transfers. But for rusting, there are basically two main ingredients required: oxygen and water. Iron loses electrons to oxygen to form iron oxide, that is basically rust. So this is oxidation. On the other hand, oxygen atoms grab those electrons from iron, and that is reduction. Now imagine Mars was like one giant apple slice but covered in iron. Over billions of years, that iron reacted with tiny amounts of water and oxygen, forming rust-like minerals. But here's the twist. What scientists just found on Mars isn't old boring rust, it's ferrihydrite. In Earth, ferrihydrite forms in wet, cold and oxygen-rich places like mountain springs and ancient oceans. So, what does this mean? Mars wasn't just dry and dusty forever. On Mars, these redox reactions not only painted the planet red, they tell a story of a planet that once had water, oxygen, or even life-friendly environment. Imagine there are two beakers. Beaker 1 is filled with iron nails, little water and oxygen, whereas beaker 2 is filled with iron, more water and oxygen in cold conditions. Now after a while, beaker 1 forms rust, that is red solid hematite in other words, and the iron in beaker 2 forms ferrihydrite. So Mars seems to have had beaker 2 conditions long ago. Think of Earth's oceans today, loaded with tiny microbes, fishes and other unknown organisms. Now think of ancient Mars. Ferrihydrite might just be a breadcrumb trail left behind by some microorganisms that once used to exist on Mars. It's funny how on Earth rust is considered as destruction, and on Mars it's the reason why life never really died. So next time when you look up at the little red dot on the sky, remember it's not just the color